Many environmental and social projects depend on people or businesses changing their behaviour in some way. The degree of change varies, and therefore we need to account for this when we're conducting a benefit cost analysis of those projects or policy changes. I'm going to use the word adoption to be a very broad, all-encompassing word, meaning things like compliance with the requirements of the project, cooperation with the project, uptake of the desired practices or behaviour change. So I'll roll all of those words under this general phrase, adoption. Accounting for adoption requires you to think about a number of different factors. You need to identify all the changes in behaviour that would be required to achieve the targets of the project. You need to identify who has to change. Then you need to predict realistic levels of behaviour change given what will be done in this project. Who will change, where will they change, how much will they change? And then given that pattern of realistic behaviour change or adoption, what would the realistic level of benefits from the project actually be? A practical approach to trying to do this is to initially estimate the benefits of the project, assuming that you get 100% adoption, 100% uptake of the required behaviour changes, and then follow that up with estimating a realistic level of adoption, which could be perhaps a percentage level, and then scale down the potential benefits to reflect the realistic level of adoption that you think will actually occur. I want to define this variable A to help us with our thinking. So define A as the level of adoption or compliance with the project as a proportion of the level needed to achieve the project's goal or expected benefits. If A is less than 1, it doesn't mean that the project necessarily generates no benefits. It probably generates some benefits, but just not as many benefits as it might. So for example, if A is 0.5, that means that adoption in this project is only half of the level that would be needed to achieve all the intended benefits of the project. Now if A is less than 1, you need to have some information or be able to make some judgment about the relationship between A, the level of adoption, and B, the level of benefits. And it can be quite difficult to know what this relationship really looks like. On this slide you can see one example of a potential shape, a non-linear relationship between A along the horizontal axis and B on the vertical axis. But it's quite difficult to know whether that's realistic or precisely what shape that would take. If you lack good evidence or a good model to predict B as a function of A, and that's fairly commonly the case, then one reasonable approximation could be to assume that the relationship is a straight line. You have zero benefits when you have zero adoption, you have the full potential benefits when you have full adoption up to some certain level, and then a linear relationship between those 2 points. Now what about predicting what the level of A, the level of adoption, would actually be? Predictions require knowledge about the practice that's being advocated. That's one type of knowledge that's required. We need to know what benefits it generates for users, what's the cost of implementing it to users, how risky is it to users, how complex is it, and is it compatible with what they currently do, their existing systems or their existing preferences. We also need to have information about the people who we hope will adopt the practice. So we need to know things like how much do they care about the benefits that this particular practice will generate? Do they have access to resources, such as money and time, that they would need to be able to adopt the practice? What's their attitude to risk? Because sometimes adopting a new practice can be seen as somewhat risky. What are the strengths of community networks and the existing community attitudes that might influence how people choose to behave? Then we'll be wanting to estimate adoption quantitatively. And to do this, we need to consider evidence and opinion on things like what's the current level of adoption before the project even starts? Was adoption promoted by previous programs? Because if it had been actively promoted and still not adopted, that tells you something about how likely adoption is this time. What was the success of past programs? And what are the private costs and benefits of the practice? You may be able to find evidence to support your judgments about these things from existing papers and reports. Maybe there are tools around that you can draw on to make these judgments. You could perhaps conduct workshops or conduct surveys of citizens or businesses or experts in behaviour to help you make these judgments. And if it's an activity that will have an economic impact on the potential adopters, perhaps you could do a financial analysis of the economic outcomes for them from adopting the practice. There's another sort of adoption that we also need to worry about in some projects, and that is adoption by other organisations of things that they would need to do for the project to be a success. The project might need cooperation from other organisations. For example, a project run by the Department of Agriculture might rely on the Department of Environment cooperating, such as by providing information or by fully enforcing existing regulations. What's the probability that this other organisation will actually cooperate as required? So in a similar way, you could estimate that as a probability, a number between 0 and 1, and scale down the benefits accordingly by multiplying the benefits by that probability to give an expected benefit. Key points. Firstly, not everybody adopts what you would like them to adopt to deliver the outcomes that you're seeking in a project. And it's important to consider this in a benefit cost analysis because adoption is different from project to project. Some projects have great potential but little practical benefit because of low adoption. We need to factor that in. We need to predict adoption quantitatively and then use that information to scale down the potential benefits accordingly.